We're here in Silicon Valley, and we're here at Stanford, which was the home, of course, to the founders of Yahoo, founders of Google. And there's a great venture capital ecosystem here in the Valley, and there's already been a good amount of venture capital put into energy storage. So one of the first questions becomes, why do we not have a Google, a Facebook, a Yahoo for energy storage? It's something we're going to talk about at length today. My perspective is, well, first of all, I think let me see. I'll be interested to see what we'll hear from our fellow panelists, but I think here's a few things we're likely to hear. We'll talk about power density, we'll talk about energy density, we'll talk about thermal runaway or lack thereof. We'll talk about cost per kilowatt, cost per kilowatt hour. And all these things are important. And I bet you're likely to hear these things. I'm not going to talk about any of them. And the reason I'm not going to talk about any of them is because I don't think that's the core issue in terms of scaling storage, in terms of determining whether storage is and needs to be a crucial part of our grid. And I think the key problem in storage is actually not a technical problem. These variables I mentioned are largely technical in nature. I know we have a lot of technologists in the room, so bear with me here. My perspective is that the real problem in storage is an information problem. So what do I mean by an information problem? I think it's an information problem in three ways. And these are the three questions I think we have to answer to determine whether storage is truly a scalable industry. First is, what is the value of storage at any one point in time? Now, we'll talk more about the different ways in which you can use storage. You can use storage to shift load, so the wind's blowing at 4 a.m., you shift it to 4 p.m. when folks are using it. You can do power quality and reliability, backup power, and all these things have a different value stream associated with it. The good folks at EPRI have done a great job in terms of starting to quantify those value propositions. But the grid is a living and breathing being. And so those values change at any point in time. And while we started to have some estimates of what those values are, there's also the complication that you can stack those values. You can stack those applications. So you can address more than one application at any one point in time. And by doing so, there's the opportunity cost of not addressing others. And so really figuring out what is the value of storage at any one point in time is that first information problem. Second information problem is, what is the value of storage over time? So let's say you're addressing an application, let's say ancillary services, which requires you to discharge the battery frequently. Okay? Here's the problem, is that if you're an electrochemical solution, you have a finite cycle life. So let's just say you have 10,000 cycles before your battery dies. Now, by addressing the highest value applications, let's assume for a second that the highest value applications are those that require you to discharge your battery frequently. You are incurring the cost of a shorter operational life. So for 10,000 cycles, instead of it lasting 10 years, it lasts 5 years. Now, that may or may not be the right approach to using storage on the grid. But have we really looked into quantifying what the trade-offs are in terms of addressing those high discharge, high cycle value propositions versus taking the hit in terms of the operational life? No. So that, in my opinion, is problem number two, which again is an information problem. What is the value of storage over time? Third and most importantly, which is a huge information problem, is not only what is the value and cost of storage, but also what is the value and cost of whatever the relevant alternative is to storage. Now, again, going back to applications, for pretty much every way in which you can use storage on the grid, there is a non-storage alternative which can address the same issue. So, again, load shifting. You can put a gas-fired turbine on the grid. Turn on a peaking plant at 4 p.m. and you have the power to address that kind of load you get at 4 p.m. on a sunny afternoon here. We can quantify that. We know what that costs. We know it works. And it is not a replacement for all storage, but it addresses many of the applications that storage addresses. Similarly, load shaving, which is essentially trying to take down from a demand side, trying to take down a load at 4 p.m. We can do that with demand response, in part. You've got big companies like Internoc, like Converge, who built businesses around this. And we know the value proposition there. We know it works. That addresses the same issues that storage addresses. So Eric has been nice enough to say, I can't use the term Holy Grail. And I'm going to violate that right now as the first one. I'll take a shot afterwards. So I'm going to tell you that the Holy Grail is actually not building the best and coolest battery. The Holy Grail is something, to me, much more mundane and perhaps boring to you, but I think is the real key to making this a scalable industry, which is this very ugly, very simple chart here. If we can figure out what is the marginal value of storing, depending on the application, of storing a megawatt or a megawatt hour of energy, and the cost, the marginal cost of storing that megawatt or megawatt hour, and even more importantly, the cost and value of the relevant alternative to storing that megawatt and that megawatt hour. If we figure that out, if we can put numbers there, I'm going to tell you that storage is going to be a scalable industry, going to be a crucial part of the grid. But I'm telling you that we don't know the answer, and no matter what anyone tells you, we don't know the numbers on that chart. So here's how I'm going to end it, because I know we have a lot of graduate students here. We've had Yahoo, we've had Google come out of this place. Please, 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 don't go build the next Angry Birds. This is an industry that is worth your time and effort. I've spent 4 years of my life dedicated to it. I find it fascinating. It is a worthy pursuit. It is not easy. But let me tell you, if you solve it, not only are there tremendous societal, environmental rewards, there's tremendous financial rewards as well. I guarantee you that. So, no Angry Birds, solve the information problem, and fix this with me. Thanks.